Hi students, welcome to our YouTube channel NECNTV ET247. I am Ayesha, working as the Associate Professor in Mathematics, Narayana Engineering College, Nellore. Today, I am going to explain Unit 1, Matrices in Linear Algebra and Calculus, R23 syllabus under JNTU Anantapur. So, in Unit 1, the first topic is echelon form of a matrix. We are reducing the given matrix into echelon form by applying row transformations. So, here we are going to find the rank of the matrix by using this echelon form. So, first of all, you must be familiar with zero row and non-zero row. So here, if you observe these examples, in this example, I have one zero row. This is called zero row. In a row, if all the elements are zeros, then that row is called zero row. In a row, if at least one non-zero element is there, that row is called non-zero row. So if you observe here we have two zero rows and two non-zero rows. Here we have four non-zero rows. So first we will explain what is the echelon form of a matrix. If we have, in applying row transformations, if any row elements are completely zeros, then that row must be below the non-zero rows. That is first point. Here if you observe, zero row is below non-zero row. If you observe here, zero rows are below non-zero rows. Next, second point. The first non-zero element in a non-zero row is 1. If you observe here, this is non-zero row. Here the first element is 1. In this, the first non-zero element is 1. Like this, we have all ones here, starting number. This is second point. Next, third point. The number of zeros before first non-zero entry in a non-zero row must be less than the number of such zeros in the next row. If you observe here, so this is non-zero row, the number of zeros, the first non-zero entry element is 1. Here before this element we have 2, here 4. So the number of zeros are increasing here, 1, 2, 4 like this. So here we have 1 0, here 4, here 4. Here we have 1 0, 2 zeros, 3 zeros. So this is the structure of echelon form of a matrix. Next, how to find the rank of a matrix in echelon form? Rank of a matrix is equal to number of non-zero rows. Here number of non-zero rows are 3. Here number of non-zero rows are 2. Here number of non-zero rows are 4. In this, rank is 3, in this rank is 2, in this rank is 4. This is the first topic, that is how to find the rank of a given matrix by using echelon form. So the second topic, normal form of a matrix or canonical form of a matrix. We are reducing the given matrix into these forms are called normal forms. Into normal form by applying row and column operations. So here we have IR. This IR means unit matrix of order R. So here rank is equal to R. In normal form of a matrix, rank is R. So these are the structures of normal forms. Okay, this is second topic. The third topic, finding two non-singular matrices P and Q. For example, if we have A m by n matrix, we are writing m, im, a, in. If we have square matrix n by n, then we have to write in, a, in. So here our aim is we are reducing this matrix into a normal form by applying row and column operations. So here if we apply first row operation, then we have to apply that operation to im, prefactor of a of RHS, and every column operation to in, post factor of a of RHS. Then finally we reduce the matrix A into normal form such that we will get here PAQ. These two are non-singular matrices P and Q. So finally we are going to find two non-singular matrices P and Q such that PAQ is equal to normal form. Here also can find rank. Rank is nothing but R, small r. Because here we have in the normal form IR00. So here rank of A is equal to R. This is the third topic. Next topic is Gauss-Jordan method. Using this Gauss-Jordan method, we are going to find A inverse for the given matrix A. So that A should be square and non-singular matrix. In the first step, we write A n by n is equal to in A. Second step, we are applying row operations to A of LHS and same operations to in of RHS. So like this we are applying row operations and finally we are reducing A into in, unit matrix of order n, which is equal to BA. So finally B value is nothing but A inverse. Next, Cauchy-Binet formula. So in this formula, first we have A m by n matrix and B n by m matrix. By Cauchy's-Binet formula, we are finding det of AB. Here we have three cases. M is greater than n, m is equal to n, and m less than n. M less than n, three cases. In the first case, if you see the first case, when m is less than n, here I am taking one example to understand this case. So here A is 2 by 3, 2 rows and 3 columns. B is 3 by 2, so 3 rows and 2 columns. By Cauchy's formula, I am taking det of AB is equal to, so combinations of, in the first matrix, I am taking the combinations of columns. Here I am taking C1 and C2 combination, C1 and C2, and det of this submatrix. So next, in the second matrix, I am taking R1 and R2, same R1 and R2 combination, rows. And we are multiplying these two det values, and then in the second term we are taking C1 and C3 columns of A and R1, R3 rows of B, and the third combination C2, C3 of A and R2, R3 of B. If you calculate all these det values and if you add all these things, you will get minus 28. Like this, we are calculating det value when m is less than n. So So number of rows are less than number of columns when m is less than n. So here m greater than n, its value is 0. So next, det of AB, m is equal to n, we are calculating det A into det B individually. So you will get det of AB value. So this is about Cauchy-Binet formula. So next topic is system of non-homogeneous linear equations. So these equations are in the form that is x plus y plus z is equal to 4 like this. Here we are going to solve these equations by using matrix methods. First, we have to write the matrix form of these equations. Ax is equal to b is matrix form. Here A is coefficient matrix, capital X is column matrix of unknown variables, B is column matrix of constants. What is meant by consistent and inconsistent? If the given system of equations has solution, then the system is called consistent. If the system has no solution, then the given system is inconsistent. How to check this consistent and inconsistent? First of all, we must write augmented matrix. Augmented matrix, it is denoted by A given B or A slash B. So first we have to find the rank of this augmented matrix by reducing into the echelon form. How we will get this augmented matrix? By attaching these elements of B to the last column of A, we get this augmented matrix. We are finding rank by reducing into the echelon form. If that rank row of A by B is equal to row of A, if both ranks are equal, then the given system has solution. If the two ranks are not equal, then the system has no solution. For unique solution, row of A is equal to row of A by B is equal to n. Here n is number of variables. Here we have number of variables are x, y, z, 3. So like this, we are comparing the ranks with the number of variables. If both are equal, all are equal, then the given system has unique solution. Then infinite number of solutions. Next topic is system of homogeneous linear equations. So these equations, the matrix form of these equations are Ax is equal to 0. So this system of equations has either a trivial solution or an infinite number of non-trivial solutions. Trivial solution means zero solution. That is x is equal to y is equal to z is equal to 0. So how to check this one? If rank of A is equal to R, which is equal to n number of variables, then the given system has a trivial solution. If rank of A is less than n, then the given system has an infinite number of non-trivial solutions. Next important point is the necessary and sufficient condition for the existence of non-zero solution is that A is equal to 0. If in the given problems any coefficient is unknown, then in order to find that lambda and mu values, we are using this case, that A is equal to 0. Next, coming to the Gauss elimination method. So, how to solve the given system of equations by using Gauss elimination method? First, we have to write augmented matrix. Here we have taken some small example, and here we have written augmented matrix. By applying row transformations to this augmented matrix, we are reducing this matrix into upper triangular form. Upper triangular form means if below the diagonal elements, all elements are zeros, below the diagonal elements, then that form is called upper triangular form. So after getting upper triangular form, we have the equations like this. And by back substitution, we are finding x, y, z values. So this is the procedure how to solve the given system of equations by using Gauss elimination method. Next method, Jacobi method. Jacobi method is an iterative method. Here we have taken one example. These are the system of equations. In order to apply Jacobi method, first we have to check the given system is diagonally dominant system or not. If it is diagonally dominant system, then we can apply this Jacobi method. What is meant by diagonally dominant system? If you take the diagonal elements in this matrix, that is 8, 11 and 12, modulus of 8 is greater than the remaining coefficients of these variables, that is mod minus 3 plus mod 2. Next, so this modulus of this diagonal element is greater than remaining elements, that is sum of two elements, modulus of 4 plus modulus of minus 1. So here also for the third equation, this is also satisfied. So the given system is diagonally dominant system. So we can apply Jacobi method. Next point, we have to write x in terms of yz and y in terms of xz and z in terms of xy. In the iteration 1, first take initial values as x is equal to 0, y is equal to 0 and z is equal to 0. If you substitute these values in these equations 1, 2 and 3, you get x1, y1 and z1. Now iteration 1 is completed. Next iteration 2. In order to find x2, y2, z2 values, we are using x1, y1, z1 values in equation 1, 2 and 3. Then we get x2, y2, z2 values. In iteration 3, we are using iteration 2 values. Like this, we are repeating the process until last two iterations values are approximately equal. Then we stop our iterations. That is the final answer, approximate solution to the given system of equations. This is about Jacobi method. Next, last topic is Gauss-Seidel method. This is also an iterative method, and in this method also we have to check whether the given system is diagonally dominant system or not. After checking this one, the given system must be diagonally dominant system, then only we can apply Gauss-Seidel method. So, in the first iteration, we are taking initial values y is equal to 0 and z is equal to 0. Using these two values, we are finding this x1 value in the first iteration. If you put y is equal to 0, z is equal to 0, you will get x1 here. Then, in order to find y1, here we are using x1 before value, this x1, and z is equal to 0, you will get y1 value. and Z1 value. Here we are using X1 and Y1 to get Z1. This is iteration 1. Coming to iteration 2. In order to find X2 value, we are using Y1 and Z1 values here, Y1 and Z1 in order to find X2. Next, in order to find Y2, we are using this X2, that is above value X2 and Z1. And to find Z3 value, here we are using X2 and Y2 before values, two values we are using here. Like this, we have to continue the iterations until the last two iterations values are approximately equal. Then we stop our iterations, then that is the final solution to the given system of equations in this method. Thank you. Thank you all. Subscribe our NECN TV and ET 247.